Today's lesson is on how to pick the best method for solving quadratic equations. Let's first talk about the different methods. The first method we're going to talk about is factoring. When do you use this? You use when the equation can be factored. How do you know if it can be factored? One easy way to tell is if the discriminant is a perfect square. Remember, the discriminant is b squared minus 4ac. All right, the next property for solving is the square root property. This one you use when there is no bx term. All right, the third method, completing the square. You use this one when ax squared and bx are divisible by a. The quadratic formula works on any problem. And lastly, we have graphing. You're going to use this when given a graph. You can also use the calculator graphing feature and check and see if the roots are clear and easy to see, which will not always be the case. When roots are rational. Okay, let's do some problems. Problem number 1, 10a squared minus 10 equals 630. My first observation is there is no bx term, so I can solve by the square root property. So I'm going to isolate a. So I'll add 10 to the other side, then divide by 10. So a squared equals 64. Square root both sides, a equals plus or minus 8. So those are your two answers. You could also put this one in the calculator. If you were going to put it in the calculator, you would need to make sure everything was on one side. 10x squared minus 640 and hit graph. And you see that the x-intercepts are positive and negative 8. All right, question number 2. Also, there is no bx term. So we'll solve by the square root property. So isolate k, so 3k squared minus 4 from both sides gives you 126. Divide by 3. K squared equals 42. And square root both sides. And there is not, that cannot be simplified any further, so plus or minus root 42. If you put this one in the calculator, 3x squared minus 126, and hit graph, you see that it does not hit at integers. It actually hits positive and negative square root 42, which is an irrational number. All right, number 3, x squared minus 8x plus 15. This one you should notice is factorable. There are 5 and 3 multiply to give you 15 and add to give you 8. You could also check the discriminant, b squared minus 4ac. So negative 8 squared minus 4 times 15. 64 minus 60 is 4, which is a perfect square. So you know that this one factors. All right, so I have x and x, 5 and 3, and they both need to be negative. And then when you set them equal to 0, you get x equals 5 and x equals 3. If you put that one in the calculator, you would see that the x-intercepts were positive 3 and positive 5. All right, moving on to number 4. Go ahead and move 7 to the other side. So you have a squared plus 16a minus 1. That one does not factor. There is nothing that multiplies to give you 1 and adds to give you 16. You could also do the discriminant to see that it does not factor. 16 squared minus 4 times negative 1 gives you 5, which is not a perfect square. Okay, so my two options now are to either do complete the square or quadratic formula. And my a value on this one is 1, and a and b both divide by 1. So this is an easy one to do complete the square on. So a squared plus 16a plus a blank minus 1 minus a blank equals 0. So I have half of 16 is 8. 8 squared is 64. So 64 on both of those. So I have a plus 8 squared minus 65 equals 0. A plus 8 squared equals positive 65. Move the 65 over to the other side. Square root both sides. And then lastly, move the 8 over. So A equals negative 8 plus or minus square root 65. That's an irrational number. If you tried to put that one in the calculator, you would not get exact values. All right, and for the last one, let's go ahead and put it equal to 0. Minus 22. If I tried to factor that, let's do the discriminant b squared minus 4ac to see if it factors. So 8 squared minus 4 times 6 times negative 22. 8 squared minus 4 times 6 times negative 22 gives you 592. And that is not a perfect square. So it does not factor. And 6 and 8 don't both divide by 6 evenly, so I'm not going to complete the square, so I'm going to do quadratic formula. So negative 8 plus or minus square root, I've already done the discriminant, 592 over 12, 2 times a. And I want to simplify that. It breaks down to 16 and 37. So I've got negative 8 plus or minus 4 square root 37 over 12. And then I'll divide all of those by 4. So negative 2 plus or minus square root 37 over 3 is my final answer. Again, those are irrational. So if you tried to do this one in your calculator, you would not get exact values.